Okay, in this video what we want to do is talk about three other functions that we can do with the DEM. This is to calculate the slope, the aspect, and the curvature. Slope is the easiest, so we'll take a look at that first. So here we're just trying to get a model of how the land changes. So you would expect some steeper slopes up in this area. These would be relatively flat. So this is the tool that we'll use, slope in the spatial analyst toolbox. Now, slope, just like hillshade, is going to have the same sort of issues. So anytime you're using, anytime you're calculating values based on a DEM that's registered in degrees rather than meters, you're going to have to set this z factor according to the correct value. Or you can project your data so that the x, y, and z coordinates are all in the same unit. So since we have a projected raster already, we're going to go ahead and use that. So this is a raster. This is the National Elevation Data model at 1/3 arc-second resolution, but we've reprojected it into UTM. So we'll use that UTM raster, and we'll create a slope raster here. The z factor, as I said, is the same as before. This is a ratio that's going to describe the relationship between degrees and meters at the specific latitude that you're at. Since we talked about that in the last time, and since we're using projected data, we can use a z factor of 1 here. The output measurement, though, we want to pay attention to. So you have your choice of outputting these things as either degrees or percent rise, which is rise over run, or percent slope. These two are very different, so you want to make sure that you're aware of what you're outputting and that it meets your meets your requirements. I'm going to use degrees here, so we'll hit OK. This will take just a minute to calculate, so we'll be back in a second. Okay, the slope value has been calculated. So each cell in the raster now has a value of a slope. If we zoom in up the upper left-hand corner, we see that this is an area where we had noted that there were sort of getting into the mountains and the area around Colorado Springs. So we'll zoom in on that. So you can see that we've got these red values indicating fairly steep slopes. By default, these are going to come back classified in this kind of a way so that our slopes at our lower slopes are green and our higher slopes are red. You can change the symbology here just like you could with anything else. Let's run that tool one more time because I want to compare the degree slope, which we just calculated, and instead this time we're going to calculate percent slope. So we'll change the output measurement from degrees to percent rise, and we'll hit OK. So this will just take a moment to calculate. We'll be back in a second. Okay, percent slope has been calculated, and one of the things that I want you to notice is that these values are much larger. These values go definitely above 1, and it looks like some of these values are quite steep indeed. So we've got values up at the 373 range, fairly steep slopes in terms of percent. If we uncheck that box, you can see how this compares. Obviously, the symbology is going to play a role here, but we are calculating different things. The way that those numbers change in accordance with the land is going to be different, so just be aware of what you're calculating when you do that. Let's take a look at aspect. So aspect is the direction that a slope points. So if we calculate that, we're going to use an input surface. Oh, there we go. Rather than using the 3D analyst surface aspect, we're going to use just aspect. So input raster is going to be the same projected raster. In this case, it's not that sensitive. It's not sensitive at all to whether or not you're using degrees or meters. That makes no difference in terms of what direction that slope points. So it doesn't really matter whether you're using a projected surface or not. We'll save this as the aspect, and this will just take a moment to calculate. Okay, aspect has been calculated, and what you can see is that we're getting a sense of which direction that these slopes point. This is the default symbolization that comes up as a result of the aspect tool. So we've got classifications for flat, but the numbers that appear in here are going to range between 0 and 360. Again, the azimuth that slope points towards. So we've got north slopes in this range, southwest slopes in this range, and so on. And you can change the symbology here in any way you like. The last tool that we wanted to take a look at was curvature. So what this is going to do is it's going to tell us whether that slope is sort of bulging out, going in, is it round, is it concave. So we'll show you what that looks like here in just a second. Curvature, like hillshade and like slope, is going to be sensitive to the units that are coming in. So you do want to make sure that you're using a projected raster, or else that you set this Z factor accordingly. We're going to output 3 different rasters from this. So one is going to be just the curvature. And the other 2 are 2 different kinds of curvature. One is going to be profile curvature, and the other is going to be plan curvature. So I'm going to bring up the lecture slide here. Profile curvature describes sort of as you move upslope or downslope, whether that bows outward or inward, whether it's concave or convex. Planiform curvature is going to be sort of whether or not sort of the slope or the curvature of the hill bends inward or outward in sort of a different axis. So both of these can be important when we calculate the output curvature. That's going to be sort of the composite of those 2. But we can take a look at both of these, and there are times, as we pointed out in lecture, times when these can be very valuable in visualizing the terrain. So profile curvature and plan curvature. And so we're going to be calculating 3 different rasters. This is going to take a moment, so we'll be back in a second. Okay, our 3 curvature surfaces were calculated. You can see these up here in the upper left. Let's take a look at the base curvature value here for just a second. And we'll zoom in on this to get a sense of what's going on. Again, what this is telling us is whether we have high curvature or low curvature, whether it's bowing out or in. So there are these values here. Let's turn on profile curvature so you can get a sense of what this is doing. This sort of has an appearance looking a lot like contour lines. So it's kind of rings that go around a slope. Plan curvature is going to really highlight especially the ridges and valleys. So if those are a part of your analysis, plan curvature can really be helpful in finding those. And again, curvature is the composite of those 2. So valleys and ridges show up fairly well. Sort of the rings show up in a little bit less sense than in this one, but they're still there. So there's your introduction to curvature, and we'll wrap it up. Thanks.